Hi, my name is Luke Thomas, and I'm a Field Applications Engineer at Solego Technology. We're going to be looking at the I2C functionality of our GreenPAK family, learning how it operates, and discovering some examples of it in use. I2C is a two-wire interface that allows circuit ICs to communicate on a shared line. Understanding the power of the PAK's I2C functionality starts with understanding the basic PAK architecture. GreenPAK is fully configured with an array of only a couple hundred bytes. These bytes tell the PAK how to connect the blocks together and what properties each block should have. Now, with I2C, you can rewrite almost any byte, which means you can dynamically change connections and properties. Let's see how it works. On Powerup, the contents of the NVM array is loaded into the RAM array. This RAM array is in fact volatile, so changes here will be lost when the power is removed. The RAM contents now configure the macro cells in matrix connections. Now, looking at the I2C GreenPAK architecture, we can see that the I2C block has direct access to the RAM array. That means that any byte that configures a property of the GreenPAK can now be dynamically rewritten. With this functionality, you could change the logic of lookup tables, adjust analog comparator thresholds, tweak timings or change clock sources, and even make a GPIO expander by tying the outputs either high or low. Let's look at some special additions to the I2C functionality. The first is the I2C virtual input block. This is where the I2C block is visualized in the software and gives access to all the general I2C properties. The power control enables or disables the I2C functionality. I/O latching is used to enable or disable I/O latches so that there will be no changes on the output while configuration settings are being changed internally via I2C. The control code selects the slave address, and you can choose up to 16 different slave addresses. Here the software will tell you the bytes that you need to write in order to read and write from the specific slave address chosen. Another feature of the I2C capability is an 8x8 RAM array that can be changed via the I2C master. It can also be set initially in the PAK. The virtual input block is not only a placeholder for I2C settings, but the outputs represent a special byte in memory, where each bit is driven on these lines. We call them virtual inputs because with just I2C, you can virtually set 8 signals. Tie them to output pins to create an easy 8-bit GPIO expander, or use them to control other logic in the PAK. Set their initial values in the Properties panel. In the same way there are virtual inputs, there are also virtual outputs. A virtual output lets you read the status of GreenPAK logic levels from any point in the matrix. This is really powerful because you can now see the state of internal lookup tables and ACMPs via I2C without having to expend external pins. This saves a lot of I/O and greatly increases your debug capabilities. Virtual outputs also provide the current counts in 4 of the counter delay blocks. This is useful for counting the number of detected inputs, maybe button presses, or determining the length of an input pulse by counting clocks. Now we've seen the capabilities of I2C on GreenPAK, let's look at the onboard tools of the Universal Development Kit. These tools can be enabled by selecting the Enable I2C Tools button. The first one we'll look at is the I2C Virtual Inputs. By clicking on it, we can see that there's a couple of different options that we can choose. The I2C Virtual Inputs allow us to select new values to output that are going to go into the virtual input. Whenever I click write, the log screen will show me when it was written, what device it was written to, and all of the data that was written. This is very helpful for recreating your own I2C commands by seeing what the dev board does. Another feature of the I2C virtual inputs is looking at the register values. You can read the entire sequence of the chip and scan through. You can also rewrite by double-clicking on the new value, changing it to what you want it to be, and then selecting write. You will see it show up in the log. Another feature is the I2C virtual outputs. If we click on it, we can see that there are options to select matrix inputs, which will show us all of the data in each matrix input. We can read to get the updated values. We can select them independently or look at them all together. The last option is the counted data. As the counters are changing in value, we can continuously read or read on demand to see new values that are in the counters as they change. They will be updated in the value section. That wraps up not only the I2C functionality built into the GreenPAK, giving you the ability to see into every matrix connection and change everything on the fly, but also the tools supported by the Universal Development Kit that harnesses the power of these great new features. Thanks for watching. For more information about GreenPAK products, visit us at www.solego.com.